We need to set up an integral for the area of the shaded region, and then we're going to evaluate the integral to find our area. In this one, we are just going to be looking at problems 1 and 2 since they are very similar, and then we're going to be looking at 3 and 4 because there is a difference. So let's start off with 1. With 1, if we know the actual theory behind this, the way I'm looking at this is we need to find the area, right? That's obvious here. And so the area, what we're going to do is we're going to break this up into sections, into little rectangles. And we need to find the area of a rectangle. It's length times width, or height, however you want to write it. I'm just going to write it as length times height. And, or a more common way is height times width. And so we know that we can write it up to down like this, or we can write it left to right. Now the reason why we're writing it up to down like this is just because that's the way I looked at it. That's simply it for this problem. For some problems, it does matter. For this one, it does not. So we could write it like this if we wanted to. However, I'm just going to stick to writing it like this. That way it will come in handy when we look at example 3 and 4. So when we look at this, whenever we find the area under a shaded region, we need to take the integral. And when we take the integral, since we're going like this, we're going to go from this spot to this spot. That's the entire shaded region. So we're going to be going from x equals 0 to x equals to 2. And so the height of this, if we are looking at the height, it's just going to be this top part minus this lower part. And this top part is 3x minus x squared. And then we have minus, we can put this in parentheses, our x. So that's the height. And now what's the width? Well, the width is this area right here. And because we have rectangles and they're continuously moving this way, we have a change in here. And whenever we have a change, we have a delta. So we are basically going to have a delta x, or d of x. And that's how we would write the integral. Now we can combine this. It's very basic integration. We're going to combine this here. It's going to become a 2x. Taking the integral of 2x is just going to be x squared over 2. So that's going to give us an x squared here. And then we take the integral of this, and we're going to have a minus x cubed over 3. We're going to have our bracket out here, and we have to have our limits. Now we're going to plug them in. So 2 squared is just 4, minus 2 cubed is just 8 over 3, and then we have minus 0. And so this is going to be your answer. You can just plug this into a calculator. I believe that'll just be like 12 over 3, and so that'll be like 5 over 3. And that would be the answer to this part, to part A. Now we're going to look at part B. In part B, this one, we have to use the up and down like this. If we were to go sideways, well, we have an issue because we would be looking at the same line. We can't look at the same line. That is a problem. So we have to go up and down like this. And we're looking from this region to this region. We don't look at this region because it's not shaded. We don't need to do that. And so let's write our equation. We're going from x equals 0 to x equals 1. And whenever we write our rectangles inside like this or like this, we're going to use x. We're going to be dealing with y's in the next video when we look at 3 and 4. So when we look at B, we have our limits from 0 to 1. We have the equation. We're going to do the top first. So we have e to the x minus our bottom, which is the x squared. And then we have our width, which is d of x. And so taking the integral of this, we know the integral of e to the x is just e to the x. Our x squared is just x cubed over 3. We have our limits 1, 0. So we can plug these in. We have e to the 1 minus 1 over 3 minus, and then we e to the 0. Anything raised to the 0th power is just 1 minus 0. And we could plug that into a calculator, and really e is like 2.7, so we would have like 2.7 minus 1 over 3. And this would be the answer. And that's how we would go about solving these. In the playlist linked below the like button, in the description, we're going to be looking at problems 3 and 4, which is going to be just like this, but a little bit different because we want to cover all scenarios.